Advanced GraphRag 2, the next 5 families. Let's dig in. In Module 1, we broke the first inherited assumption, that a graph is always worth its language model bill. Today, we break the next one, the quiet belief that your corpus sits perfectly still. Every graph we have built across both courses was assembled once over a fixed pile of documents, and then treated as though every fact inside it would stay true forever, because obviously nothing in the world would ever be so rude as to change. Charming world. It is not the one your agent has to live in.
Meet Dana Reyes. For over a year, Dana was the Chief Technology Officer at Meridian Labs, and your assistant indexed the company wiki in February, when that was completely true. In March, Dana left for Helios Systems. In April, a new hire asks the assistant who runs technology at Meridian, and it answers instantly, fluently, with a citation attached, and it names Dana. Fast, well-sourced, and wrong.
Here is the uncomfortable part. Nothing malfunctioned. The extractor extracted correctly. The retriever retrieved exactly the right edge. The generator faithfully reported what that edge said, and the citation points at a real document that really did say it in February. Every component passed its own tests, and the answer was still wrong, because the graph had nowhere to write down the sentence, "This used to be true." That is not a bug in your pipeline. It is a missing feature in your data model. Picture 2 tracks running side by side. On the top track, the world moves. Dana is at Meridian in February, hands over the badge in March, and starts at Helio the same month. On the bottom track, your index does absolutely nothing because you built it in February and it has been asleep ever since. In April, the question arrives, and it gets answered from the sleeping track. That gap between the 2 tracks is not a rare edge case. It is the normal condition of any system that indexes once.
What makes this genuinely dangerous is how quiet it is. There is no stack trace, no timeout, no suspiciously low confidence score, no red banner, nothing to alert on. The answer arrives fast, reads beautifully, and carries a genuine citation. Your dashboards see a perfectly healthy system. Your user sees a fact. Only the world knows the difference. And the world, unhelpfully, is not on your on-call rota.
And it compounds. On day 1 after indexing, almost everything you stored is still true. Every week after that, a few more facts quietly retire. People change jobs, prices change, policies get replaced, projects get canceled, teams get reorganized by someone with a new whiteboard. Nothing in the store notices any of it. So the share of your memory that is silently expired only ever moves in one direction, up, and it climbs faster the more interesting your domain is. Now, the temptation is to jump straight to a fix. Resist it for 2 minutes, because the fact changed is not one situation, it is 3. And they want completely different things from your system. Teams that skip this step build a single mechanism, apply it to all 3, and end up with a memory that either forgets things it should have kept or keeps things that were never true in the first place. So let's separate them before we build anything.
Here are the 3, drawn on a timeline. A correction. The fact was never true and you recorded it badly, so the old bar gets struck through and replaced. A succession. It was genuinely true, and then the world moved on, so one bar ends exactly where the next one begins. And an expiry. It was true for a window everybody already knew about, and that window simply closed. 3 different shapes, 3 different responses. Take correction first with Dana. Suppose your extractor misread an org chart and stored that Dana Reyes was VP of Engineering at Meridian Labs. Dana was never VP of Engineering. That title belonged to somebody else entirely. So there is no interesting history here about the world. The only history is about your own mistake.
This is the one case out of 3 that is genuinely your fault, and the only one where the old value describes nothing that ever happened.
Succession is the common one, and it is not a mistake at all. Dana really was Chief Technology Officer at Meridian Labs for over a year, and everything you stored about that was correct. Then, in March, Dana left and Priya Raman took the role. Both statements are true. They just belong to different stretches of time. If your memory treats this like a correction and throws the first one away, you have just deleted a year of accurate history to record 1 day of news.
Expiry is the sneaky one because the end date was known in advance and nobody wrote it down anywhere the system could see. When Dana left, Meridian issued a 90-day contractor badge for the handover. That badge was genuinely valid, right up until it wasn't. And here is the catch. No new document ever arrives to announce it. Nothing contradicts an expiry. It simply runs out. A memory that only updates when new information shows up will hold that badge forever.
Put them side by side, and the design lesson falls straight out. Correction is a defect. Fix your extraction, and the wrong value is not history anybody needs. Succession and expiry are the world behaving completely normally, and there, the old value is not garbage. It is the record of a period that genuinely existed and that somebody will eventually ask you about. So any fix that treats all 3 identically is going to be wrong 2 times out of 3.
So what do most teams reach for? 2 things, and both of them fail, which is genuinely worth knowing before you spend a quarter building one of them. Fix number 1. Rebuild the whole index on a schedule, every night, like a very expensive alarm clock. Fix number 2. When a new value arrives, write it over the old one and move on with your life. Let's take them one at a time because they fail for completely different reasons.
Rebuilding nightly does work, in the narrow sense that tomorrow morning your graph agrees with the world. The trouble is what it costs. You pay the full extraction bill again across the entire corpus to move a handful of facts that actually changed. And in between runs, you are still serving yesterday's answer. So the window where you are confidently wrong never actually closes. It just becomes shorter and more punctual. Meridian's news broke at 9 in the morning. Your rebuild runs at 2. But here is the fatal objection, and it has nothing to do with cost. Imagine your rebuild is instant and free. Somebody asks, who did we think was running technology at Meridian back in February? A perfectly fresh index cannot answer that. It knows exactly one thing, the present, because every rebuild quietly erases the one before it. Freshness and history are different problems, and reindexing, however fast you make it, only ever solves the first one. Fix 2 is cheaper and far more tempting. A new fact arrives, you find the old edge, you write the new value straight over it. Done. One update, no schema change, everybody goes home early. Watch what leaves with it, though. The moment Dana's old role is overwritten, the statement Dana ran technology at Meridian until March stops existing anywhere in your system. Not archived, not marked retired. Gone, and gone silently. That loss has a bill, and it arrives later, usually at an unsociable hour. An engineer gets paged because the assistant gave a customer a wrong answer last Tuesday and needs to know what the memory contained last Tuesday. A reviewer asks, reasonably, why the system said what it said. In both cases, the honest answer is a shrug, because the evidence was destroyed by the very update that fixed the problem. You cannot debug a system whose history you deleted. 2 reflexes down, and notice they failed in exactly the same place. Both of them treated time as a nuisance to be flattened, rather than as something to store. So let's stop guessing at fixes and do what you would do for any other requirement. Write down what a memory that survives change actually has to do.
5 obligations, in plain English, with no vocabulary you need to look up. Everything in the rest of Part 2 exists to satisfy these. So, before we look at a single system or a single line of code, let's write down the bill, because this is the checklist we will hold every product in Part 2 against. Remember when a fact became true. Separately, remember when you found out about it. Notice when something new disagrees with something old. Retire the old version instead of erasing it. And answer questions as of any moment we choose. 5 obligations, and every clever thing ahead is engineering in service of exactly those. Of those 5, the first 2 carry most of the weight, so let's sit with them for a moment. Dana's move happened in March. That is one date, and it belongs to the world. Your assistant did not actually read the announcement until July. That is a completely different date, and it belongs to you. Keep only one of them, and you lose the ability to answer half the interesting questions, including the ones your on-call engineer asks at 2 in the morning. 2 dates on every fact. Hold that thought. The 4th obligation is the one that saves you at 2 in the morning. When Priya takes over the role, the honest move is not to delete Dana's fact. It is to mark where it stopped applying and leave it exactly where it is. The old fact is still there, still queryable, still pointing back at the document it came from. Your memory grows rather than churns, which costs you a little storage and buys you every audit conversation you will ever have. And once nothing is ever destroyed, the last obligation becomes almost free. You can ask what is true right now. You can ask what was true back in February. And this is the one that surprises people. You can ask what your system believed in February, which is a genuinely different question, and the only one that explains a bad answer from back then. Same store, 3 questions, no rebuilds, and no apologies. So that is the case for the prosecution, and here is the plan. Parts 2B and 2C give every fact its 2 dates and teach you to ask questions as of any moment you like. Part 2D handles what happens when a new fact disagrees with an old one, closing it rather than deleting it. Parts 2E and 2F introduce the real systems that implement all of this properly with names and interfaces. And 2G asks the hard question. Can you replay what your memory believed last quarter? And do you actually need to? 4 properties. See you in 2B.
If you like this video, please subscribe and share. Thank you.